All right, let's start again. Okay, so the tides come from differential gravitation. So the Earth is pulled by the moon, pulled gravitationally by the moon. The moon, of course, is pulled gravitationally by the Earth. And what that does with the Earth is because a large fraction of the Earth is liquid. There is a noticeable bulge in the direction of the moon. That's actually not exactly in the direction of the moon, but we'll get to that in a little bit. Anyhow, on the opposite side of the Earth, what happens is the water will pile up, 180 degrees away, and this is caused by what's called inertia. If you, for example, took a bucket of water and you started spinning it, the water would pile up at the bottom of the bucket, and if you spun it over your head, for example, the water would, if you moved it fast enough, the water wouldn't come out. And so that's what's happening. This is high tide. Over here is high tide. This, of course, would be low tide, and here would be low tide as well. And so what happens is some point on the Earth, some random point, Myrtle Beach, for example, rotates into the high tide, rotates out of the high tide. It rotates, so rotates into the high tide, and then out of the high tide into the low tide. The tides are roughly 6 hours apart, and then rotates into the next high tide, and then rotates into the next low tide. And you would think that in a 24-hour cycle, you would be back to the high tide again. But here's the problem: is the moon has moved, right? And it moves appreciably because, of course, the moon is the closest celestial object to the Earth. So it's moved a good fraction. It's moved about almost an hour, a little less than an hour, about 50 minutes. So that if, let's say that this high tide occurred, you were in Myrtle Beach, and it was the highest tide happened right at 9 o'clock in the morning. The next morning, it wouldn't be at 9 o'clock, it would be about 9:50 because the moon has moved. All right, now, let's see. So there are other effects too. The moon is, the moon has a stronger pull at what's called perigee. Perigee is the closest point the moon is to the Earth, and then apogee is the furthest point. So whenever those happen, that also affects the tides. So that's just from the fact that the moon's orbit is elliptical, as all orbits are. And here's the thing. Here's the big thing that affects the moon, or affects the tides, is when the Earth and the moon and the sun line up. So let's say that if the sun were over here, and you had a high tide. So the sun were over here, and let's say that the moon were either in new moon or 0 degrees or 180 degrees. Either way, it doesn't matter. What happens then? That's called a spring tide, and those spring tides. It has nothing to do with spring. It happens all the time. The spring tides are just when the phase of the moon, it's a high tide, and the moon is a new moon, or the moon is a full moon. And because of that alignment, the sun adds to the tidal effect. Okay, because it's gravitation. Now the sun, of course, is so far away that it's actually roughly half as effective as the moon is as far as the tides go. But so during spring tides, you have the highest high tides and the lowest low tides. So it's the biggest extreme, the biggest swing between high and low tides. And then now think if the moon were over here, let's say we'll keep the sun in the same position, and the moon were over here, so that phase would either be first quarter or last quarter, right? So when the moon and the Earth and the sun are at 90 degrees to each other, right, either first quarter or last quarter, then what happens then, and that's called a neap tide, is that the sun is actually canceling part of the tidal effect. Okay, just because of the angles, and what happens there is now you're having the lowest high tide Okay, the lowest high tide. It's still a high tide, but it's the lowest it's going to be, right? Because the sun is canceling out some of that, and the highest low tide. And so the extremes are going to be the smallest. The difference between a low tide and a high tide, when it's neap tide, is going to be the smallest difference. And the differences can be, just a few meters. It depends on where you are on the Earth, and it also depends on, how the water, how what's surrounding the waters. I mean, even lakes have tidal effects, but you generally don't notice that at all, because it's just such a slight effect on a lake. But if there's like an opening, it depends on the shape of the opening and so forth. But some of these tides can be major. I mean, you can have huge differences in tides. I guess one of the things to note is, like, for example, the Gulf of Mexico only has, as it says here, only about a third of a meter or so, whereas these different bays and things like that around the world have this much larger, even larger than 3 meters difference, which is what you see generally around the ocean. So it varies from location to location, but even the land, my goodness, even the land is affected by the tides, right? Because it's differential gravitation. But it's because that's a solid object, it's not even noticeable. You would have to have special equipment to actually measure that. All right, I think that's it. All right.